Hi, welcome to video 6.8 on graphing quadratics using critical values. So far when we have been graphing quadratics, we've been finding the roots and then finding the axis of symmetry by looking exactly in the middle of those. And a lot of times that's a great way to go, but sometimes it doesn't work as well because our roots are not something that's a whole number. So we've got our standard form of a quadratic function is a squared plus bx plus c equals 0. And our axis of symmetry, there's a formula for it, and it's negative b over 2a. So we take negative b divided by 2a, and that gives us the axis of symmetry. And then our vertex is going to be whatever this x is in there. So we're going to take whatever our axis of symmetry is right here, and we're going to put that into the equation, and then we will get our y from that, and then our y-intercept is going to be whatever when we put in 0, and if we put in 0 for for x like that, we're going to get c, so it's going to be 0, c. And then of course parabolas are symmetrical, so that means whatever we do on one side of our axis of symmetry, we can do to the other. And sometimes that'll give us kind of a free point that we didn't have to calculate anything for. Okay, so the first thing we're going to do is the axis of symmetry. So we're going to do negative b over 2a. So negative b is going to be negative 2 over 2, and then a is negative 2. So that's negative 2 over negative 4, which is 1/2. And so I'm going to put 1/2 in there. And then I'm going to put 1/2 in here into my x. So if I put negative 2 and then 1/2 squared plus, 2 times 1/2 minus 1. This right here is negative 2 times 1/4 plus 1 minus 1. So plus 1 minus 1, cancel each other out, and this is just negative 2 times 1/4, which is negative 2/4, or negative 1/2. So this is negative 1/2, and that is going to be a maximum. It's going to be opening down because it's negative. So I can go ahead and put my vertex of 1/2, negative 1/2, about right there, and I can do my axis of symmetry, which is going to be going down that way, and then I know it's going to be a max, so I know it's going to be opening down like that. My y-intercept is going to be c, which is negative 1. So here, that's going to be there, and that's going to be there. And then right now, it says use my axis of symmetry to make symmetrical points, so I did that, and then connect the points to make a parabola. But that's kind of a little space for me to know. I mean, and it's okay if you want to draw that, but I like to do at least one more so I kind of know what's going on in another spot. So if I put 2 in here, negative 2 times 2 squared, that's negative 8, plus 2 times 2 is 4, minus 1, so that's going to be negative 5. So 1, 2, 3, 4, 5, like that, and it's symmetrical. Whoops. It should be right there. So it looks like that. You could use the first 3 points if you want to. Just nice to be a little more specific. Oh, whoops, I'm sorry. It should be, yeah, it should be right there. Should have been there. Okay. No, I'm sorry. 2, yes, at 2, and so that's 1.5 away, so that is 1.5 away as well. Yeah. All right, sorry if that was confusing. Let's try another one. So axis of symmetry, negative b over 2a. So negative b is going to be negative 4 over 2, 1. So that's going to be negative 2. So we've got negative 2, and then I stick that in here. So negative 2 squared plus 4, negative 2 plus 3. So that's going to be 4 minus 8 plus 3, which is negative 1. So I have negative 2, negative 1. I'll go ahead and put that as my vertex and my axis of symmetry like that. It is positive, so it is going to be a minimum. And then my y-intercept is going to be my c value, which is 3. So at 0, 3, 1, 2, 3, and then I'm going to use my axis of symmetry to make symmetrical points, so it's going to go over here, and then that is a good enough curve for me to draw my parabola like that. And that's it on this one. I don't feel the need to do any other points because I think those 3 points define my parabola pretty well. Okay, I would like you to try this one down here. So pause the video, give it a try, and then come back to check your work. Okay, here is the answer for that one. It should look like that. I did an extra point on this one, but you didn't necessarily have to. Okay, let's take a look at one of our application problems. All right. So Ben shoots an arrow. The path of the arrow can be modeled by this function right here. Y represents the height and feet of the arrow. X seconds after it's shot into the air. We're going to graph the path of the arrow. So we're going to use our critical values. We know the y-intercept is 4. So I'm going to go ahead and mark that. 1, 2, 3, 4. And then my axis of symmetry is going to be negative b over 2a. So that's going to be negative 6 divided by negative 2, which is 3. So my axis of symmetry is going to be at 3, like that, which means I can have a symmetrical point over here. And now I'm going to look for my vertex. So if I put 3 into here, what will that give me for my y? So negative 3 squared plus 6 times 3 plus 4. So that's going to be negative 9 plus 18 plus 4. So 9 plus 4 is 13. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to go up like that. And so now I can draw my curve. And then what height was the arrow shot? So there's my graph. The arrow was shot at 4 feet high, which we can see because that's where it starts. And then the maximum height of the arrow is going to be 13 feet. Right there. Okay, and then don't worry about this one. We need a graphing calculator to do that one, so we will work on that one later. Please write down anything that you are struggling with, and we will talk about it in class.